some gist of Spark, right? How it was like, what was the mind for the developers when they started looking out? They started creating this Spark. What was the blocker they were working on? Because they knew that the Hadoop is taking long. MapReduce is doing lots of read and write operation. So why not let's create a cache of used memory, crunch all the data, and then uh, give the result back. Okay. Now there is a challenge, right? If you are doing everything in memory, there's like yesterday we discussed that there's a chance of losing that if any machine goes turned down or power off or anything can happen, because this framework was devised for the commodity hardwares. Commodity hardwares, we say it like normal machines. You don't need the bare metal, or you don't need the fully sophisticated machines. It was a framework to run on any sort of computers. So just a second. Okay, so they created they written Spark by but Spark had some chartered keywords. Why I'm saying chartered, because before Spark, it was those things were not considered or given much importance, and you will see that how important is that now. So the first thing Spark did is that it launched with the programming language. It was agnostic to the programming language. It said that you can write in the Scala, you can write in the Java, and you can write in the R. So the first variant, I mean, what I remember was Scala, R, and Java. Very initial. It started supporting these three languages. Spark was written in Scala. By default, it was supporting Scala. It was also promoting Scala. Then, since Scala is written in Java, so implicitly you get the support in the Java. You can use Java for sure. Then R was the one wrapper written because of why, we'll see why R was given an importance. Spark launched with machine learning libraries as well. Earlier, I think Apache Mahot, this was the name. I'm confused with the name. No, I mean, if the pronunciation is not right, maybe you might get confused. But this was the name, Apache Mahot. This was launched in the Hadoop framework. So Spark was doing, the MapReduce was doing the data processing task, and Mahot was doing the machine learning part. So this was a mathematical library of doing all the regression, classification, and etc. So Spark said, I will also reduce MapReduce. I will also reduce Mahot. I'll give you a common framework. And R was being used by the old age engineers. Old age engineers, I don't mean like old age. What I'm saying is that R was being used for the scientific research from long time. R was like a high level language, and people were very familiar with it. So R wrapper was required. Anybody who was willing to provide support to the machine learning, or machine learning was not a not a key thing that time. That time machine learning was means you have to do some R. So Spark said, I will provide the machine learning library and I will give you the R wrapper. So if you know R, you can start using the Spark ML. Okay. Later, they have also added SQL and Python. So now these 5 programming languages are the key programming languages. So if you want to believe me, if you have to believe me, you'll have to see me. And to believe this, see, If you see this slide, Java, Python, R, Scala, and it doesn't have SQL because SQL is primarily considered as a scripting language. It was never considered as a programming language. We are talking about the programming language. What's the difference? I will talk about. But the point is, you see the trend. Red Monk publishes it like Gartner, like what the Gartner does. That what are the most famous languages these days? So it's a recent. I think I had taken it last December. So it may be 5 months old, but Java, Python has strongly picked up with the Java, and Scala is just coping up with Java because of Kafka and the Spark, the two major component. I'm saying component, but I mean framework. Framework was written in Scala, so whoever is using Kafka and the Spark, technically they give some edge to the Scala, and the Scala picked up. So these are the languages. So that's why the Spark thought, if I have to compete, I have to give support to the R because of the machine learning, and I have to give support to the Python because Python programming language is taking a leap ahead among all other languages. So that was the reason. Okay, but besides that, we were here. So we were talking about creating a cache of memory and putting it putting data onto it. That was one of the concepts. But technically, Spark said I will have a pool of memory, 10 GB each from all the worker node, and then I can process 50 GB of data. Then there's this should still be the question for you, that I'm processing it, but how come it's reducing that read and write time? I mean, still, if this worker has done the task, like in the Hadoop or in the MapReduce, if this worker has done the MapReduce task, it will write the result somewhere. This will also write the result. This will also write the result. So read and write will still be happening in this Spark. So what's the difference, right? I'm not sure if so far we have discussed about the Spark has the capability to crunch the data in memory, and then since it's crunching in memory, it's not like I can forgive you for read write. I mean, you will still do the read and write, right? So what you are doing with the read and write? So what Spark does with the read and write is what important. So let's see that. So that comes with the capability of, no, I don't want to type. That comes with the capability of this word, lazy. Spark is lazy, and it's beautiful because it's lazy. And believe me, what do we say? This is just one liner, but it should be remembered. Spark. I mean, according to me, Spark was the first language which took the privilege of being lazy. And after this, you'll see lots of languages like TensorFlow also take a pride on being lazy. TensorFlow. Lot of language has been developed, and then they take a pride on being lazy. Only the PyTorch is something which is eager. But the point is, when the Spark was launched and it started saying that I'm lazy, people were like, I mean, what's that? That's something which was there in the programming world, but people were not sure that this lazy could be used so beautifully in the distributed programming practice. So we are talking is about Spark. And then we are talking about lazy. So, okay, to understand lazy, I will do a couple of things, okay, from the base. I understand we are, you know, lots of things, but just for the confirmation. So let's say I will just rename it as C1, C2, C3, C4, C5. This is a data set, right? Typically, this is what we call table, 2D array, and this is what is called, oh, sorry, tables. So we understood that concept, right? The RDD and the table. So table. Okay, no, I think there's one thing which I could elaborate. Table is a 2D array, which is like Excel. So it's a 2D array. We also it looks like Excel. It's a short sort. Excel is example of beautiful 2D array. But then this table was Spark was launched. So I'll go in the flashback. I will talk about Spark in terms of RDD. Okay. So because right now we don't know the other sophistication of Spark. I'm talking about RDD. And now let's say this is A, this is B, this is C, this is D, D. Let's call it A, B, B, C, C, D, D, E, E. Let's say this is A1, A2, A3, A4, A5, P1, P2. Okay, so initially when the Spark was launched, it was not working with the direct tabular structure. This is a tabular structure, right? This is a table, and we call this a tabular structure. This is a tabular structure. RDD was not tabular. RDD was key value pairs, key and values, and it was a map of key value. Map we all know, right? So this is a map, like name, name, and the name value is something. Address and address value is something. So this is a sort of map. So these using these keys, you can access these values, right? So that was the concept for the RDD. RDD said, you give me the data set, and I will create a resilient data set in key values pair, because Java, it was Java and a scalar driven program, and in Java, table means collection. I mean, I'm not saying table means collection. Table was a collection was the only API to work in Java, and collection topmost element was it was a map. Java has implemented map concept, which is dictionary in Python, which is known as key value pair. It had different names, but the point is collection had string, collection had array, it has list, it has linked list, it has map, it has concurrent hash map. It has hash map, it has linked hash map, it has concurrent hash map. So map technologies was very much optimized. What Java used to do, Java used to optimize map. See, I will give you the best map, key value pair. I will give you all the sort. If you have the interest in the data structure, you would know how to traverse in the matrix, how to traverse in this, how to traverse in that. All those questions are important, right? A matrix is given, and then you have to find something. If a matrix is given, you have to do something. If it's a chessboard, if it's a etc. Questions are related to the data structure, right? Binary tree, etc. All those questions were being answered using Java or any programming language by using map. So map was a very sophisticated alternate of table. Okay, now see, I'll go a little deep inside. So map, and now you know that I have said the map was a interface. So map was implemented by various ways. We had hash map. Let me know if you have heard it or you would like to know anything in detail. Okay. Map, it had hash map. It had linked hash map. It had concurrent hash map. It had linked concurrent hash map. There were more as well. Okay. There were a lot more hash map implementation, but this concurrent hash map was picked up for RDD. Concurrent hash map. I will give you a concurrent access to the hash map. How is it? Like, okay, so if this is clear, maybe I will draw it somewhere else. But is this clear so far? See, we had a table. Table was the best way to work. But when Spark launched, Spark was written in the Scala and the Java, and Java had the best representation of table as a map. And in the map, it had the concurrent hash map. Concurrent hash map was best version of the map, which was taken. These things are only important only if you want to know the underneath, what happens inside. So let's say now I will create a map.
Of hash map look like this?
Sorry, I didn't. Can you repeat, please?
Yeah. How does the structure of hash map look like?
Yeah. So I'm just plotting it.
Okay.
So Keshav, Java has all the concepts, all three types of hash maps.
Yeah, Java has concepts. Java is like
Java supports all the three types of hash maps.
yes. Java supports, in fact, many more than that. What I have listed are the few important ones. What I have listed is I can tell you the concept of all of them, but what I have listed is a hash map, linked hash map, concurrent hash map, linked concurrent hash map. Okay, so these are the crux of Java. These are this is the beauty of Java. Without this, if you attend any Java interview, there would be, if 10 questions will be asked to you, 8 questions will come from these stuff. Which map you use, what do you do with the map, and etc. etc. Okay.
Okay.
Yeah. And Python made it simple and introduced dictionary, and then said that okay, fine, you use just dictionary. and I'll give you all these if you want. So I'll come to the Python later, but what I'm saying is Java is a low level, and Java has all the implementation, and you need to pick the right collection element to do your work. Okay, now I'm coming to this. I've drawn something, right? Where did it go? Okay, so so now we are trying to understand the map, and then we'll see using the map, we'll understand what is linked map and what is concurrent hash map and etc. So in map, technically there is a key, and then there is a value, and this is also the key concept of. Don't get confused, but this is how the why the JSON was also developed, because the Java was very suitable working with the map, and JSON took this advantage and converted all the data structure in the key value pair. It just used a different notation. So map says I will have key and I will have values. So I will have keys, like, let's say I will give some keys. Okay, I will give some useful keys in the beginning, and then I will use some random. So let's say name, I will use ID, I will use age, I will use tell me what else I can use. I'll use gender, salary, and then let's say I'll use some random ABC, BCD, and DEF. Okay, and then it has a name like 01, XYZ, 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 XYZ. So this is a map, right? You know, this looks like a dictionary as well, right? You search for a word, and then you find the value of it. Like you search for, what do you mean by cleansing? You search for the word cleanse, and then you see, okay, cleansing means sanitization, or cleansing means cleaning something. Or cleansing doesn't mean cleaning something. Cleansing will mean to I don't know, sanitize something. So every word will have the synonyms, and then that's how it's described. But in the map, similarly, if this is one of the object in Java, right? This is a employee object, let's say, and it's coming from the employee table. So I can have multiple like this, right? If I have multiple employees, I can have multiple key values pair.
Yeah.
Here I could have Praveen's information. Here I could have your information. I mean, Tuhina's information. So the point is, in just the key value pair, I can also give a structure to the table, right? In table, what this becomes, this name becomes column, and these values becomes rows, right? But we have done the reverse. So map is like a list of key value pair. Okay, clear?
Yeah.
So map is a list of, let's say, Keshav, Praveen, Rohina. There are 3 employees, and I have a map, and in that map I have 3 elements. So if I need to fetch my information, so what I will do, I'll do index I equals to 1. So it will fetch, and then get, I will do get name. Right, so it will give me this name. If I'll set index 2, it will give me this name. It will set index. So I can start a for loop and I can get the details of all the maps. Clear?
Yes.
Praveen?
Yeah. Yeah, Keshav.
I hope nobody is sleeping, right?
No.
It's early morning, I understand. And it's getting boring, I know. Is it getting boring?
No, it's not boring.
No. So get name is used. Get name is a Java function. So you're just making us
GetName is
understand
not a
that.
Java function. When I will write, okay, so I don't know from where you are getting your questions, but
Mhm.
it makes sense. GetName is implemented in the employee method, employee object. So when I
Okay.
will describe the employee object,
Mhm.
I will describe this GetName function.
Okay.
Yeah. So I will first instantiate this employee object.
Mhm.
Employee object will get populated by these values, but the
Mhm.
map is created. Once the map is populated,
Mhm.
then on this index, I can do a get name and get this, get ID and get this, get age and get this value.
Okay.
But get name, get ID, get age, get gender, all those functions will be written in the employee object.
Okay.
Okay.
Mhm.
All right. So now this is a map. Let's say now for this map, if I won't give this a hash value, a, B, C, some alphanumeric hash values. Hash value, you know, right? Hashing something.
Yeah.
So hash value means I'm giving this huge alphanumeric number by using a hash algorithm like digest base 64 or RSA algorithm, or I'm using an algorithm which cannot be reversed, but with that once the hash value is generated for this object, it will always remain the same. So using this hash value, I can always access this. Okay. So for every element in this, in the hash map, a hash value will be automatically created by the Java. So if this is one row, I will create a hash value for this. And with this hash value, Java will be able to make some modification in it. Let's say you want to update the ID or you want to update the age. You can fetch this hash value and then update this. Because this is a map, so you'll do the insert, update, delete operation on this, right?
Yeah.
On table, we do insert, update, and delete operation. So table is map is a replica of the table. So in on the map also you will do the insert, update, and delete operation. So when you are doing this, how will you you have to fetch it fast, right? So to fetch this value fast, you'll use a hash value of it, and this hash will be returned to you. This hash will return you this. You will just go and instead of doing the set name, you can get name, you can do the set name, and in the set name you can pass, and instead of KT you can pass 80, anything you can update it, you can set the name. So the point is hash map has given you the faster access for your index. You don't have to iterate, you don't have to, because right now you don't know where is that value. So if I'm setting that where name is KT, I will write code like update this map where name is KT. So the hash value has to be picked, right? If the hash value will match, then I will get this record, and I'll put this update set the value name equals to 80. So it will set this value. So hashing helped in accessing the object in the map. So the hashing was hash map was a beautiful example. Then came the concurrent hash map. Let's say it's in Spark, there was a need of distributed processing. So sometimes what could happen, you are writing in this chunk of the values. Now when you are writing, right? Whenever we try to update some values in database or in any map, we try to take a lock, thread and lock mechanism, right? We take a lock, we update the operation, and then we come out of it and release the lock so that other can go and update it. Other thread can update this. So imagine this like a restroom, where where a thread enters, lock itself, does its work, comes out of it, and then the other thread can enter. So that was a problem. That was like, if one thread is updating this structure, then it has taken a lock on the entire hash value. And at the parallelly, when I'm doing set name, I cannot do the set gender as well. First I have to do the set name, then I have to do the set gender. But this is absurd, right? If I'm doing set name, I can just take a lock on this block, and this block I could still have released so that the other thread could update this. Okay.
Okay. So this concept is concurrent hash map.
This concept is concurrent hash map. I'm giving the concurrency on the hash map. Beautiful. So that was the idea. So
But hash value is given to every element in the hash table, right?
yes.
Okay.
So I think in this diagram, I created the table. So let's say if this was your data structure and you created you have created a map. So you would have a map as a list of 5 list. Your map would have key value, key value, key value, key value, key value, 1, key value, key value, key value. So it would look something like this. I think if I could use Excel, it would be better to demonstrate it. So let's say C1. I'll use just few rows because I need to create that as well. So I'll just use ABC. ABC. I think I should use some simple than random so that I can also modify this. ED, ED, CC, ED. So if I have to create this as a, first we'll see if I need to create this as a JSON, what would be done. The JSON would look like, it will be in an array, sorry, it will be an array, and in that array would have an I'll write it here rather. It would have an array. Array would have one object, two object, comma, three object. Enter. And this would have I think if I go by JSON notation, let's say I'll just put the value. Okay. Right, and this will be repetitive in other elements. So if I'll use the same values, what I've used it here, this also looks like a table, right? It has all the meaningful values. I think I'll make it 2. I'll make this 3. So if 1, 2, 3 is the primary key, I can access the values, right? It's just that it's not in the tabular format; it's in this format, and this is called the map. So this is a one. This is one map. This is one map. This is one map, and in total, this is a list of maps. So it's a list of map or hash table. I mean, like you said, hash table or hash map. Anything. There is a difference between hash table and hash map, but right, currently we can live with the hash table. That is fine. But you understood, right? So concurrent hash map gives us the access to just fetch this element and modify this. So concurrently, 2 threads can work on this object. Concurrently, multiple threads can have access to the same element, same hash of that map. So concurrent hash map, if I have to define, I don't know. I mean, of course, I know that the definition, but if let's say if it doesn't suit like the layman how I'm writing, it is just allowing the thread to modify the hash. It is just allowing the thread to modify the map concurrently. Okay? That's called the concurrent hash map. And you already have the hash, so you fetch the hash first, get the element, and then let the multiple thread work against it. And that's how the Spark said, okay, I will do that. So the concurrent hash map become the concept behind the. So when we devised RDD, we leveraged the concept of concurrent hash map and we made it go distributed on different data nodes. So concurrent hash map was distributed. It went to the different data nodes. Now we all know, right? Concurrent hash map can be concurrently accessed. So RDD finds a suitable candidate. Now nobody will ask you at this level of detail. So I know this could be boring for you, and parallelly nobody will also. I mean, nobody bothers to understand all these details. People prefer to say that, oh, I don't know Java. But the point is not the Java. The point is the concept, that whether you understand what is within the RDD or not, how the table can also be an RDD, and why there was a requirement when RDD moved, when RDD had a transition to data frame and data set. What was the requirement for that? To understand these things in detail, we need to understand this. At least we could, in a very bad day, at least we could answer that. What was the concept behind? So RDD took the concept of the Java of concurrent hash map and then distributed it, and then gave it a resiliency and laziness, two concepts. And then if I will add lazy and resiliency to the concurrent hash map, it will become the RDD. Simple. Okay. So far we have heard lazy, but what's that lazy? So now I think we'll move to the lazy concept. But as of now, any question? No? Good. So now we are moving to the part of the lazy. So what's so great about being lazy. Again, I'll explain in my words, like what a lazy person does. Unless it's very important that if I won't get out of the bed, the things will, I mean, maybe that the milk will spill, or it will go something will happen if I won't get out of my bed. That's being lazy, right? Sitting idle, not doing anything, just thinking. I mean, okay, I'm planning something. So procrastination, you heard these words, right? I'm thinking of doing something. So what I do, what I keep thinking lots of time, and then I just go and do and finish the work, and then I start thinking. This happens, right? It's a phenomenon. It happens with everyone. So people, even the proactive people, also to some extent is lazy. I mean, proactive people are they are always being called into the action, and that's why they are into the action. But the if given the time or given the opportunity or whatever, the lazy is the thing which people prefer. They want to keep. They want to sit idle, plan the stuff, and then I'll go and do the stuff. So plan this stuff. That's the first thing. If you're just lazy and not planning, that's called a different. That's I don't know. That's called foolishly lazy or something. I mean, if you're sitting idle and not doing anything, even not planning, then that's lazy is different. That's not the spark laziness. Okay.
Yes.
So what spark laziness is then? Spark said, okay, I will do one thing. What do you primarily do? You do insert. So the spelling is not this. You do insert, update. You also do select. Select is a I think I should have written select first, but that's fine. And delete. Okay. You this is called CRUD. CRUD operations. Update, delete, create, read, update, delete. Okay. So you do whatever you want. You want to insert it. You have to call the action first. So the thing is, what I will do, I will create a plan. Let's say you have written a statement like uh, select star from this table. I mean, I'm not saying that you have written something, but uh, let's say you're trying to do something like this. You are selecting something. So you have selected. Then what should I do? You have selected. That's fine. Now what? Okay. Okay. Now I have selected. I want to persist. I want to write. So remember this word, persist. I have done some operation. I have done insert, update, select. Whatever I wanted to do, I did that. I wanted to take the count. I wanted to do the max, min, etc., etc. Everything. As long as I'm not calling the persist method, I'm not. I'm not saying just the persist. As long as I'm not calling the action. The keyword is action, and the action qualifies for save, persist, coalesce, etc., etc. There are a couple of keywords. Okay, save me as temp file, write me as CSV, write me as view, etc., etc. As long as I'm not calling action, I can do all these things in memory. I mean, you have as long as you are doing these operation, I'm just preparing a plan for you. What I will do. So let's say we'll take an example. So let's say if somebody wants to first read a CSV, okay? Then he wants to select some columns. Then he wants to apply some filter, like year equals to 2020. I've applied a filter. I have read a CSV and I've applied a filter. Now I want to do some aggregation. Give me some count, max min, aggregation. As I think G is missing. Aggregation, like count, max, min, and etc. I want to do some aggregation. Okay, no problem. After aggregating, I want to do some join with some other table. I think join could have come earlier, but let's say I want to do join as well. I want to apply some filter on this as well. I want to sort it. Sort by descending. I have done all these things, okay? In my onto my RDD in the Spark. Spark didn't do anything. Spark has just created a plan. Okay, first I will select CSV, then I will filter some record, so I will get only this record. I will have only this record. Then I will apply. I will do aggregation, so I will get this, and then I will apply. I will be joined by some other table, so I will do a join. Then I will apply a filter, and then I will be sorted. Okay, so Spark has created a plan. We are calling it as a DAG, directed acyclic graph. So Spark was not doing anything, but it was creating a plan for you. How I will execute your task. So these are called transformations. So for all the transformation you do, Spark doesn't do anything. Read a CSV was an action. I mean, a Spark had to go to the desk and read something, right? So this was the first action. And then after doing everything, when I do the persist, when I call the persist method, till I call the persist method, Spark was busy in preparing the plan for you, a beautiful plan that I will do this, I will do this, I will do this. And then when I called a persist method, then what happened? Spark went, read the CSV, selected column, filtered, aggregation, joined, filtered, sorted, did it everything in the memory, and then persisted it. So one read and one write. Possible only because of this DAG. Because I have prepared my plan. I didn't like, I have selected column, then I went back and written it. I filtered some column, then I went back and written it to the drive. I did the aggregation and I've written it to the drive, etc., etc. I didn't do anything like that. I read the CSV. I tried to accommodate that CSV in the memory. Even if that CSV was larger in size, I tried to use some drive. I tried some mechanism. I will come to that mechanism later. But for the simplicity, now you just have to understand that Spark is lazy. It keeps preparing the plan for you, and plan is called DAG, which is directed acyclic Graph. Okay. So every word has a meaning again. Directed, acyclic, and graph. It is directed, right? I am going in a directed mode. First, I will read the CSV. Without reading the CSV, I cannot select column. Only after selecting the column, I can apply the filter. If I have not selected the year column, I cannot apply the filter. If I have then I will do the aggregation. Without applying the filter, if I will do the aggregation, I might be aggregating all the year of data, right? So I have to prepare a sequential plan. I will do this, then I will do this, then I will do this, then I might take some decision, and I will go in this path. I will do this, I will do this, and then finally I will conclude at some point. But this plan is needed. This plan was something what the Spark was preparing before calling a persist method or save method. Save. So I'm emphasizing on persist, but don't get confused. Save, persist, collect, collase, all these are actions. And when you call that action, then like show, you in Database you have seen, right? So describe, view, head, tail, head 5, tail 5. When I do head 5, tail 5, it tries to go and execute the plan and then get that data set. Before that, it was just creating this plan on the master node. Clear?
Yeah.
It would be clear. You would have question. In fact, I have lots of it, which I'll continue. But the point is, this DAG concept also became very famous. So every programming language started thinking, oh, I should give DAG, I should give something. Oh, I will plan, and then I will just execute for your action. So that I could save the, I could do lots of things in the memory. So because the DAG was introduced in the Spark, it was okay. So we have only spoken about the directed. We are still to speak about acyclic. Acyclic means this is not circular. It doesn't mean that after persisting I will go and read the data set again. If I have persisted it, this DAG will be trashed, and I will create another. So the graph creation starts when you start reading something, and then when you persist something, that DAG goes off. You have that structure either in the memory or something, but this structure is gone. Because if I'll continue to have this structure every time, you'll call this database and our data frame, and I'll do this stuff. So once this data frame is saved in your memory, this okay. I'm sorry, I'm referring data frame here, but so far we have not introduced data frame. So let's say the RDD. So I have this RDD, and I will retain. I'll keep this RDD. I will not create the graph now. Whatever you will do on this RDD, I will create that graph. So it's not cyclic, it's acyclic. Once from this to this, what happens? Let's say in between, if the power goes off, I have the graph. So when the power will resume, I will start running from this end to this end. I will run it again. So I will not resume from anywhere. But let's say after doing this, after persisting it, sorry. How to move this? Okay, so after persisting this, once I have done the persistence, and then the power goes off, then this data frame will be lost. Okay, and then again you will read and you will do all this stuff. But let's say if this data frame was also transformed to some other RDD, still again I said data frame, but if this RDD was saved to some other RDD, then this RDD will till this RDD, you have already structured. If you have enabled the checkpointing, then from this RDD onwards, you can continue your calculation. So Spark is giving you these flexibility. It's creating the acyclic graph for you for all your transformations, and you can do the checkpointing that from where you want to resume if something bad happens. But in core world, since I was lazy, you were busy writing code, I was busy planning the execution cycle of it. So we both didn't do anything. You call save, I'd give you the result, and that's all. You didn't so I gave you the result when you did the save, so you have already saved it, so my job is done. Now you use that saved file. So this was the concept of the Spark. That's why it is called lazy.
Keshu, what if multiple users are working on the same table and trying to persist at the same time?
They would have multiple Spark sessions.
Okay, what value will get saved if they're performing same type of task on a table?
Concurrently, they could save multiple values.
Okay.
Whatever
Okay.
transfer. Let's say I am doing some. Let's say I was doing a filter on 2020. Okay, and you are also accessing and you are applying a filter on 2021. Okay, two people are working on the same CSV. So for me, when the DAG was created, I mean, so everything in Spark starts after the Spark session. Okay, for every user, a Spark session is created. I'll come to this. Spark session is latest stuff, but a Spark context and etc. But for the time being, just understand a session. A session is user specific. So if Praveen is working, for Praveen there would be, let's say, one session one, and if I'm also working for Katie, there will be session two. Now in session two, I was doing 2020 filter. In session one, you were doing 2021 filter. You saved your file. I saved mine. No interference. You read it. You brought it to the memory of the Spark, right? Spark did that calculation for you according to the DAG you have created, and then it saved your file. It saved mine. Different.
Okay.
So you cannot come into my session. Session is not a shareable object.
Right. Yeah.
Okay, so don't go to the Google and then check that, oh, session can be shared. There are other frameworks like on Spark these days. There is a concept called Ignite and etc. etc. Multiple people can share and then do that. That's a fancy stuff.
Okay.
Okay,
Yeah.
next level of thing. But the point in Spark, you cannot share the session.
Yeah.
Okay, there is a thing called Ignite in which the session can also be shared, and we both can work on the same, because we are all working against a cache, a cumulative cache. That's a different concept. Okay, but in Spark, I will work on my session, you will work on your session, you do your stuff, I will do my stuff. For my Spark session, if X amount of memory and X amount of code is required, that will be allocated to me. For you, if X amount of memory and resource is required, that will be allocated to you. Let's say when I'm executing my job and that resource is not available, you will stay on the queue. Okay. Once my work is finished, your job will be executed. So S1, S2 can work in a queue mode. Multiple session can be in the queue. Okay.
Yeah. So for these steps, for pre-planning, we should already know what should be there. Like, if in case aggregation and join, if we kind of change our mind that we have to join something else, then this won't work,
No, it will
right?
work. You do whatever you want. These are transformations, right? You do whatever you want here. You continue to change your mind.
Oh,
Spark will not bother.
okay.
As long as you have not called saved. If
Mm-hmm.
you have called saved, that means that data will be saved. but still you will go back and then change your filter and submit your job.
Okay.
But the point is, you are allowed to do it. I mean, I also and today maybe I will show you. I'll continue to do multiple tasks on the day on that data frame.
Okay.
But Spark doesn't care, because you first you aggregated based on the gender, then you aggregated based on the salary, then you aggregated based on the year. You do whatever you want. Finally, what you want, and finally what you want, that I will save, and I will run all the pre-steps.
Okay.
Okay. So now think of some challenges, because now we'll discuss uh, some challenges. Like that was a good question though. That session sharing. So if that was Praveen, like these days it can happen, but the Spark has no such concept. I will work in my session, you will work in your session. Good? No questions? Okay, all right. So I think the key things behind this Spark. We understood in memory. We understood being being resilient means. We understood what being lazy means. And believe me, this lazy concept was equally taken in the TensorFlow. TensorFlow also become lazy. And for your machine learning program also, it creates the graph, the directed acyclic graph. They call it CAG, computational acyclic graph, but the point is the same. Yeah. So they create. Okay, one more line, important. In Spark and in TensorFlow, you cannot write any program before starting a TensorFlow session or a Spark session. You have to start a session. Okay. Why? Because my code will be executed only for me. I would have my session. What is this? I will have my session. You will have your session. So first thing I will do, I will create this guy, the Spark session. And under this Spark session, using this Spark session will give me the Spark object. And on this Spark object, I will start writing the code, which you have seen, but the concept behind that is this. Just a minute, let me have some water. Where is the browser? Just allow me a moment. Sorry, I'm all the Okay, so till this point, in any question, we understood how the driver worker pattern works. Every executors will have their own JVM, because it was read. Java and Scala works together. We will also see that, but let me know if you have any doubt with this should thing written here, JVM. If you understand it, that's well and good. If not, we can discuss this also in detail. But the point is, Spark was written in Scala, Scala was written in Java, and Java runs on the JVM. So all the code will ultimately run under the JVM. And JVM will run on the OS. OS can be Windows or Ubuntu. All these workers will have Ubuntu or Windows or anything. And then on that, you will have a JDK. When you run that JDK, it will create a virtual machine, Java virtual machine. Under that, your code will run. So if let's say if this worker node has 20 GB of RAM and you have allocated only 10 GB to the JVM, so your code would be running under the 10 GB. It will not have the access to the other 10 GB. So JVM memory allocation is important. Clear? Only four or five words are written here. Anything, any question around worker, driver, executor, JVM, and etc.
Okay, sure.
Right. Okay. So now we are coming to other subject, which is like it was pain, right? We all know table. Why you created RDD? The first thing. Map. I know Java was capable of doing the map, but can you again give me back my give me the table itself? Okay. So you know this exercise we did. I mean, I tried to create a simple looking stuff in this dangerous way. I mean, looking awkward. I mean, it was looking so beautiful, and this is looking awkward, and then you're working on this. So why you're doing this? Why don't you just keep the tabular structure? I don't know. I don't care. Underneath you work with this, etc., etc. But show me something like this. That was the question. That why you are showing me these blah blah stuff, and why do I have to know all the Java, how to handle with the map, how to handle what are the functions available in the concurrent hash map, what's the functions available in the RDD, and etc. etc. Why you are being so programmatic? I can't give you some high level stuff. So this is the high level, right? Tabular structure, and everybody knew that. Okay, when I will write select C1, C2 from this table, only these two columns will be returned. So if I will write select C1, comma C2 from this table, I will have just this result. Fair enough. No, this is pretty simple. Why I have to like do like uh, start a for loop, index it, or give you the hash, or I want to fetch C1. So the primary ID of this is being hashed, and then I'll give you the hash code, and you'll give me this result back. Why all those exercise in circus? Make it simple. So programmatically, it was not simple because it was Java based. So somebody said, okay, fine, I will write a wrapper for you. You like this? I will write a wrapper. And when I say wrapper, I mean I'll give you the sophistication. I'll give you the library which you are familiar with. So RDD got transformed into the data frame, which was looking like a tabular structure. So when you hear the word RDD, you have to understand the concurrent hash map. Okay, not necessarily, but understand the how the concurrent hash map works, and that's how the RDD will work. It will have the key value. For loop will be applied to get the value. Then I can modify it, and etc. etc. I have to work fundamentally in Java. But then Spark says, I will create a data frame for you. And then you use data frame, which will give you a tabular structure, which you guys had been seeing in the database. And now you guys know what to do with this. So once you see the thing in the tabular structure, if I'll show this to someone, if I also show someone, this is my data, you'll first try to understand, okay, what is this? This is a JSON. It's a JSON, so I should use JSON library. This is a map, so I should use list hash map, list hash table, or not hash table. I should use list concurrent hash table, list concurrent hash map. He would have multiple questions. But when I would show something like this to anyone, people will say, "Oh, what is this? This is Excel." You can do all these things. Technically, you are doing these things itself using all the transformation logic. The only way is how you understand it and represent it. So data frame said, okay, fine, I will make your life easier. I'll give you the tabular representation of the RDD. And of course, I'm giving you a wrapper, so I have to give you the optimizer and etc. So that you can understand that how long your query is taking time, because your data frame is getting first interpreted into the RDD, and the RDD is getting executed and etc. Okay, clear?
Yeah, and it will take more space also, right? Creating each hash table for each element there.
It will take it will take couple of things. It will take first thing it will do is it will convert that structure into some different structure. Then it will definitely take more space for that program, for the all the objects it will create, like for all the hash table you said. Essentially in the JVM, that those will be the object in the stack, right?
Yeah.
So it's a object in memory of the JVM. It will take the space in the memory. So RDD was the core thing, but people were feeling difficult working with the RDD because it was very programmatically inconvenient for lots of people. Only Java programmer was flexible with it, but others was like SQL programmers. I mean, database guys and the business guys were never able to understand. Okay, what do you do? What kind of data you are giving, man? You need to transform it, give it in the tabular structure. Oh no, Spark writes in this format itself, which is fine, but I don't understand it. So data frame said, okay, fine, let's do one thing. I'll make it simpler. You won't see the map or JSON or etc. I'll give you the tabular structure. So that was the initiation, and I think from 2014 onwards, I think I've started using Spark. In 2014, like I was in Mexico for one of the Coke project, Coca-Cola project, and then they started evaluating Spark for one of their uh, Latin America Coke distribution. They had Netezza and they wanted to replace Netezza and they wanted to try something open source. So the Spark was that time recently added. And then it was 2014, so data frame was also not pretty much mature. We were doing everything with the RDD, but during that project implementation itself, 2014 that project started and 2015 the dataset came. So though we implemented that project in the data frame itself, but dataset, when the dataset came, we realized that that there are things what we are doing in the data frame, we could write far less number of far less code if we could use dataset. Okay, so now what happens? This is key value, right? This is key string, this is a string, this is a string, this is a string. Let's say if I'll replace this with 01 plus 04 and 2020. This is technically a date, right? But what data frame will read? The data frame will read it as a string. So what you'll do? You'll read it as a string, but since you know that C2 column is date field. So I'll convert this string into the date. So I'll use the string date formatter. I'll apply all those transformation, blah blah transformation unnecessarily, right?
Yeah.
So this, if let's say this field was written something like as one, and I don't know how, not minus one, plus one. So my num block is off. So this is technically this should infer it as a phone number, right? I'm not sure.
Yes.
If something is written as alphanumeric, you should read it as a string. This makes sense if you're reading alphanumeric as a string. But if I'm saying this as a 1, 2, 3, 4, 5, blah blah, this should be read as a float. Technically, yes. So what was happening with the data frame? The problem was we were reading the schema, but we were also defining the schema. That C1 column should be string, C2 column would be date, and then in a given bad day, what was happening? C2, in C2 there was null, so it was null pointer exception. In C2 there was some other field, like somebody has some stupid guy has entered date like this. So this has come. Now this is failing because in the simple date formatter where we have written the code, this is not parsing this code. There was lots of possibility of the failure if we are doing this implicit conversion of the data type. So data set says, okay, wait, I'll do that data inferencing, the data type inferencing. I'll do that for you. Type safe and fast. I will infer. I will see the data what the guy has submitted. If it looks like the date, I will make it automatically. I will set it as a date, and then I will accept some blah 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 format. So I will give you the options. Like let's say if it is a date field, I will allow the user to enter in this way. You can also sorry. You can also enter in this way. Caps. You can also enter in this way. These things I'll take care of it. Your program will not fail because you are running a program for, let's say, and then I'll also give you like dd mm yyyy hour minute second time zone. I'll take care of all those things. See, calendar and string is the worst thing in the programming world. String related transformation, calendar related transformations are the pain areas. It's a pain in the it's a pain. So most of the time programmer keep doing this blah blah shit that, oh, I'm just converting the string to the date or date to the string, or the format is different and I'm converting the format and etc etc. I'm replacing the okay. So for the programmer there's three problem areas: string, null, and date time conversion. These are key issues from long time. If I'll see my 15 years of time frame, still these three things are still a problem. Now, if in fact after seeing the error, I could figure out that, oh, okay, because of this you're getting this problem. But the problem is if you're starting, these will be the stuff which will be creating the problem for you. Okay. Fair enough. Moving to this, so these problem areas were targeted in the data set. Data set said, I will do the automated type inferencing. What is that? automatic type inferencing. I mean data type inferencing. Okay, this was the key concept behind the data set. So if somebody will ask you the difference between them, we understand, right? RDD had the low level programming control using the map or concurrent hash map function of the Java, and it was all key value pairs, where it was not a tabular representation of the data. Okay, but data frame gave the wrapper of the RDD in terms of representing the data in the tabular format and allowing us to write SQL. So when we say this SQL and Python came in 2015. In 2015, SQL and Python came. Oh, now you look like data. Okay, I can also work. You create a wrapper. So PySpark came, SQL came. Spark SQL came. I mean, Spark by themselves released the Spark SQL version, and then they said, okay, you write SQL query itself. Don't write RDD, get name, set name, or etc. Write your SQL queries. I'll do the stuff. I'll create the Java program for you underneath. Okay, so it was logically very well planned. It had the optimizer. These are the unwritten rules. Like obviously, if you're writing a wrapper, you should be responsible for its optimization, right? You should give something, and then of course you cannot create something which is slow. So your new thing has to be fast. So they had you can say that it is fast. This is more fast. You can say that dataset is faster, but in order to define and give the value differentiation between them, this was Java oriented, this was SQL oriented, and this was SQL plus the data type inferencing as well. So that you don't have to write more number of code. This is more suitable for some of the key problems of data frame, type inferencing, running the join queries. Like if you're, we will see that those problems. Like if we are doing a join of two big table in Spark, and then the memory is limited, so definitely it's going to fail, right? We'll see all those problems. That's because say our intent is we will target more on the Spark as much as we can. Spark and Databricks is the only thing which could a Spark, Databricks, data lake, data warehousing. 4 keywords should be there, and this would save you in terms of, I mean, in terms of the progress, in terms of the interviews and etc. Okay. Hive and HDFS, we have parked it. We have understood the concept, but it's not like if you want to know more about it, we cannot do anything. Obviously, we can spend our time in Hive optimizations as well. We can also conduct a class on the Hive optimization, but the problem is Hive is just a SQL. Hive query, you write the SQL statement, it creates the map reduce query and then run. But the Spark is not creating the map reduce query. Spark is creating your Java map functions. It is directly working in the memory with leveraging the concept of the Java. It is not creating your MapReduce was also in Java, but it is not creating the MapReduce task. Rather, it works at from the high level. It directly works on the low level. MapReduce works. MapReduce also works on the concurrent hash map. It's just that it does frequent read and write. That was the blocker, and then mapper and reducer had a layer. I mean mapper function. So over here also we have the RDD. So that's not a differentiator. The only differentiator is the map reduce was taking a lot of time because of the read and write heavy operations. RDD was reduced because it was lazy enough to. It was lazy, but when we were doing the transformation, it was creating the plan for your execution. And once the execution plan is ready and you are trying to collect the data or save the data or persist the data, it will execute your plan and save the data for you. So it doesn't do the frequent read and write, like I have applied a filter, I'll go and filter this stuff. It doesn't do all those things. It will just bring the things in the memory and apply the slice and dice in memory itself. Apply the slice and dice in memory is called Spark. Clear? Concept started with the RDD, leveraging the concept of the Java. RDD took a shape of tabular structure, data frame. Data frame got further enhanced, and data type inferencing started happening in the data set. It was further optimized, of course. Like couple of other things was also because if I'm introducing a new stuff in the world, obviously it has to be smart. Only then it could be accepted by the people. So of course, data frame is faster, data frame is performance efficient, data frame is blah 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 blah. But the difference is what it does implicitly is it give you the edge on data type inferencing of the data frame. Clear?
Yes.
Perfect. I think I should put this on charge. All right. I think I've spoken a lot. Last slide. Okay, this is something what is new in this Spark 3, but first we need to understand this Spark. So I'll come to this slide a lot after we understood all this, what is shuffle, what is shuffling, what is partitioning, what is join strategy, etc. What is skew join. Once we'll see all these things, we'll see the Spark 3 concept. But as of now, we have understood the basic of Spark, right? Is it good for us to take a break for some time?
Yes.
Okay, and after the break, we'll move to the database side. Yeah, we'll do the hands-on. Any
Yeah, how
theoretical
long we are
questions?
going to continue, Keshav, today?
Sorry,
How long we are going to continue the session today?
I don't mind. I mean, for me, it's like I will be talking to this guy. He has a data lake engineer interview, so I have continuous call. So you tell me what time till what time you guys are free.
I'm free for another 1 hour.
Okay,
I
both of
am
you.
free. Yes, I am free for another 2 hours also.
Okay, but
Yeah, we can do 1 hour.
we'll try to wrap it somewhere in the 40 minutes after the
Okay.
break.
Okay.
Yeah.
Okay, yeah.
So we'll just do the some of the hands-on because doing the hands-on will always keep you in the relevance. So
Yeah.
we'll try to do some small stuffs and then all right. So stop recording and we'll see you all after a break.